Have you guys noticed that the shell method is very similar to the washer method? They're different in that for the washer method, the rectangle is drawn perpendicular to the axis of revolution, while for the shell method, the rectangle is drawn parallel to the axis of revolution. And as we can see here, for vertical axis of revolutions, which also means rotating around the y-axis, for the washer method, the rectangle is perpendicular. And for the shell method, the rectangle is drawn parallel to the y-axis. Similarly, for horizontal axis of revolutions, the washer method is drawn perpendicular to the x-axis, and for the shell method, the rectangle is drawn parallel to the x-axis. So again, the difference between the washer method and the shell method is that for the washer method, the rectangle is drawn perpendicular to the axis of rotation, while for the shell method, the rectangle is drawn parallel to the axis of rotation. So you must be wondering, when do we know when to use which method? It really depends on the problem and the equations that are given. You have to ask yourself, is it easier to solve in terms of x or in terms of y? For more help, you could draw a visual graph so it's easier to decide which method you want to use. So for further clarification of the difference between the washer and the shell method, I'm going to show you with a pencil and an eraser. The pencil is going to serve as the y-axis, while the eraser is going to serve as the rectangles. So for the washer method, if we're revolving around the y-axis, the rectangle would be perpendicular to the axis, and when we revolve it around the axis, it's going to turn into a disc with a hole in the middle because it is washer. For shell, the rectangle is going to be parallel to the pencil, and when we revolve around the axis, it's going to be in the shape of a shell with a hole in the middle. So here we have an example with the function y equals square root of x plus 2. The graph is also bounded by the y and x axis and the line x equals 4, as seen here in gold. So in this case, the function is being revolved around the x-axis, and for the disc method, the rectangle would be drawn perpendicular to the x-axis, so which means it's going to be in terms of dx. And the height would just be square root of x plus 2 because that's already in terms of x. And so we don't have to change the equation or anything. But for the shell method, the rectangles have to be drawn parallel to the x-axis, which means it will be in terms of dy. In addition to that, we have to split this in half because the function starts here and ends here, which means this entire part is unaccounted for. And if we want to find the entire volume of this whole area, we would have to draw two rectangles, which means two separate integrals. And also, because this is in terms of dy, the function has to be switched around into x equals y minus 2 squared. So for this particular problem, the disc method would be a lot easier because it's in terms of dx, and the function's already given in terms of x, so you don't have to change the equation or anything. And because we don't have to set up two separate integrals as we have to do for the shell method.